All right, let's get started. Uh, Hello, everyone. I am David K, founder at Stately, and this is Gavin.
Hey everybody, I'm one of the back-end engineers here at Stately.
Yeah, so this is a bit of an impromptu stream, and if you saw stream alerts a few days ago, sorry about that. We had some technical difficulty, but I really want to make this a more regular thing where we just jam on workflows, state machines, just application logic in general, and maybe rant about a few things. So
I'm here for the ranting, for sure.
and everything else. So today I want to talk about serverless workflows. And so I saw this a while ago, actually, back when I was working at Microsoft. There's something called the CNCF serverless workflow specification, which is actually pretty interesting. It's sort of a DSL that lets you author your business logic, your workflows, using this. I don't want to say it looks exactly like XState, but the people who worked on this were actually definitely aware of XState, and I know that because I was in some of their office hours while I was working at Microsoft, and they were talking about it, and they said like, yeah, we know about XState, and it's a really interesting specification because if you squint, it does look a little bit like XState. You have the whole JSON object configuration type of thing. But what I found really, really interesting are all of these examples. And so these examples range from like super simple, like you have start, a state, and an end, and then you have a result. And then they show you what it looks like. And I find this really nice, actually. They show you what it looks like in both JSON and YAML. So taking this.
That's huge.
Yeah. Yeah. And it honestly, it makes me like YAML a little. Just because I know with the curly braces and everything, it's like, do I have the right number at the end? Like, look, even here, it's sort of like, well, what's going on there?
Where does that array end or start? It's difficult sometimes to parse it
Exactly.
visually.
Yeah. Yeah. But the YAML, it's just like, there you go. Although YAML has its own set of
and the set of idiosyncrasies. Yes.
Yeah. So actually, I'm going to let's see which one looks interesting. I will say this: we did make a bunch of examples already for XState in the XState v5 branch, which is just the next branch, and I did most of these. The ones that I didn't do are just these three at the end. But I'm going to show you an example of. Here we go. Perform customer credits check, which I think was pretty interesting because this is actually a more detailed workflow. It does go a little bit more in depth. So hopefully you could see that all right. We have a start state, and then we're checking the credit. And this is calling out to a credit service. So if you're used to XState, you might envision this as an invoked service or invoked
definitely.
Factor.
An invocation, one that we care about the end result for, right? So we've got that arrow going back to the credit check state.
Exactly. Yeah. So this, whenever you see like arrow here, arrow back, it's like this state is doing something, we're invoking something, and then we're getting back that event. And then we have a little, if this were a flowchart, you could imagine this as a diamond. We're evaluating the decision. The decision could either be denied or it could be approved. So we could reject or start the application.
Yeah, it's a tiny decision tree there. It's like a decision bonsai. Really small.
That's great. Decision bonsai. I like that.
Yeah, we'll coin it as a term.
I'm zooming in way too much. And then, of course, the workflow ends. So, yeah, the JSON's long. Again, it's because of all these one-line curly braces. So instead, we're going to just take a look at what the YAML looks like for here, just to sort of explain a little bit of, what's going on. Zoom in a little bit there.
I love the way it reads. I have to say, it is really straightforward.
Mostly. Yeah, while I was converting these, and maybe it's because of my state machine state chart brain, some of the things were like, that's a little bit implicit, or that doesn't make too much sense. Or, that could be a little bit more explicit. Or it was just a little confusing. Okay, so looking here, we have a bunch of functions, a credit check function. Now, they call these functions, but they're really where we're invoking them. So they're separate actors. So
Okay.
yeah, credit check function and the send rejection email function. Of course, the send the rejection email. And then we have events, and they define the events pretty formally. It's like, okay, it has a name and a type, which sort of redundant, but that's okay. Yeah, it has a source and a correlation, which is the customer ID. And then we have our states. Yeah. And so here's where it starts to look more XState-y, or state machine-y. We have it says starts check credit. So that's our initial state.
Mm-hmm.
And then we start check credit, and then it's type callback. Not sure what that is, but I'm assuming it's running this function called credit check microservice with this input. And I'm going to call it input because that's what XState calls it. So
yeah, they're calling it an argument, but I mean, same diff.
Yeah, exactly. And so I guess their point of reference is in functions, not in actors. And so in XState, you're creating an actor with this input. So the input of customer.
Yes.
And then
for the audience, David, we're specifically referring to XState v5, where everything we're trying to effectively, imply the everything is an actor sort of methodology there. Things like you'd see in Akka, and I believe it's Erlang. It's like everything is an actor in Erlang.
Yep, Akka, Erlang, Elixir, technically. I mean, yeah, and actors should be used more.
They should be used more. So you may not see, I do think we do have some actor vernaculars sprinkled in the later versions of v4, but you may not see it as explicit as it is in v5. So just wanted to give that a quick shout out.
Yeah, it's sort of like night and day. XState is mostly the same as you might have experienced between v4 and v5, but in v5, actors are definitely more of a first-class citizen, not just an afterthought. Yeah. Now let's see. We also have evaluate decision, and this is a switch, but we're going to be using guarded transitions for things like that. And then we have conditions. So like, was the decision approved? Then start the application. Was it denied? Reject, and by default, just reject the application. What's also interesting here is that this has a timeout of, I think this is 15 minutes or so. So that's cool.
It's Pacific time, 15 minutes. Yeah, that's exactly what that means. No, I have no idea.
Yeah, they have
like you believed me for a second.
No, I did. I was like, I always did wonder what that PT meant, but whatever. And then we have start application. And then this is the one part that confuses me, where we have start application and then action subflow ref. So this is by subflow ref, you're invoking an actor, I'm guessing. And then it just says end true, where it's like, hey, by the way, once the state is done, then the machine is done. And same thing for here. In XState, the final state is an explicit state. So
we call it a final state.
Yeah, this transitions to a final state. It's not like this state magically becomes a final state once this invocation is done. That doesn't make sense to me. So that's going to be one of the biggest differences. So I'm going to go ahead and stop sharing my screen so that we could actually jump to what this looks like in the code. Let me just show you. This is our, this is what we're going to try to model. Or we already did model. I'm just showing this as an example. And let me grab the name here too. This is, what did we call this? Customer credit check example. Okay. So I'm going to share a different screen. And let me actually find it. I have way too many windows open.
Oh, story of my life. It's fine.
Yeah. This is bad. I have so many windows, and I'm like, you know what? Maybe I could just narrow it down to VS Code. Nope.
I'd say
because I have.
Yeah, I get it. I'd say we could fix it with editor magic, but we're live, baby.
Yeah. So many windows open, but I promise I will find the right one. Okay, I found.
I believe. There we go.
Do I need to bump up the font size, or is that good?
I think we do a little bit. It's a little hard to see the Explorer window.
All right, cool. So, well, the Explorer window, we'll keep that small. I'm talking about like here.
Oh, yeah. The font there in your terminal is good.
Yeah, I'll bump it up anyway. Let's see, terminal fonts. Let's bump this up too. Like just 24. There we go.
Nice.
A little bit bigger. Okay, now this was the customer credit check example. And so again, in the V5 branch, the next branch, if you go to, like, all of them are prefixed with workflow, and you can't see it here, but just take my word for it. Workflow credit check. That is the example that we're going to be working on, or not working on, but just looking at for now, because we have other ones to actually do. And if we open the visual editor, this is what it looks like. I mean, we have to do some. All right, awesome. It auto layouted for me. Whoa.
Yeah, no worries. And for anyone that may be new in the room, the little hot link that David clicked there requires the XState extension, our VS Code extension. You can just go ahead and install in VS Code, and you'll have that option to open up the visual editor.
Yep, to search XState, look for the official one by Stately, XState VS Code. We do eventually need to update it with the latest version of the studio. We had a lot of exciting updates to it, so yeah, definitely check that out.
Yeah.
But yeah, so here is our state machine. And full disclosure, when I was working on this, I literally just copy pasted the YAML at the top, and then I let Copilot do its thing. And Copilot was able to get 75% of the way there, but it really saved me a ton of time on all of this. But yeah, let's look at the visual first. So we have check credit, in which we invoke this call credit check microservice. So zoom in here just to visualize that. In fact, we'll simulate. And then two things can happen. That microservice can finish up, or we could have a timeout of PT15M, whatever that means. And so then we go to this timeout state, which doesn't really go anywhere. But let's say that this actually finishes. Then we go to this evaluate decision state. And you're going to see here, it looks a little weird here. And that's because this is not updated to support XState v5, but just know that there's conditions here. And so based on the condition, we could either be starting the application or rejecting the application. And then once those are done, we reach the end. And so that's the explicit end state that I was talking about, or the final state, rather.
Yeah.
All right.
Which is great when you're thinking about it in terms of an actor model, because when you know you have an explicit end state, it's really easy to say, all right, and now deregister this entity, right? We don't have to worry about whether or not it's implicitly, done and it's hanging around somewhere. And, you might actually accidentally reference it when it can't actually do the thing you need it to do. So I love the idea of an explicit end.
Yeah, me too. Plus, you could add metadata to that. There's different ways you could reach that end state. So it's just nice for it to be explicit. Angelo says, morning, gents. It's
hey, Angelo.
Here, but
10 minutes to 5 p.m. here.
Are you in Australia? Like, what time is it over there? Anyway, so yeah, let me just go through what this looks like in XState v5, and then I'm going to take Gavin on a trial by fire with some of the examples that we haven't done yet, and we're going to see how much we could accomplish there.
A journey through the desert, I believe.
Exactly. So first thing, types. Types are super important. Instead of stuffing them in the generic, in generic types over here, we are putting them in here. So we have our customer, which has all of these fields, and our credit check, which is something that we get back from the service that we call. And it comes back with a decision, either approved or denied. And of course, we start with null at first. And then there's this new thing in context, which is inputs. And so this is actually a big change from v4. Oh, wow, I was right. Angelo is in Melbourne.
You nailed it. Melbourne.
I love Melbourne. And also you're up early. That's great. Anyway, so instead of like having a factory function to define your machine or overriding context, which is a little bit dangerous, you take the inputs. And so it's a lot safer. And then when you actually start the machine down here, you just pass in the input right there. And that's it. Right. And this will soon be type safe. We're still working on that. And so you would pass in the customer information, and then eventually it will just go through all the states and eventually come out with an output. So the way that works is once the actor is completed, so complete, we have actor.getSnapshot.output. Maybe we'll have a more idiomatic way of doing that, such as making it a promise. But for now, that's how it works.
Yeah, definitely. One thing you briefly mentioned, but I'd like to double click on a little bit, is when you define your types. And so in my experience, a good parallel to this in V4 would be what used to be known as schema, correct?
Yeah. So it was known as schema. However, types makes a little bit more sense. So
yeah, it's a bit more TypeScripty, especially, right? So it does help. I think it's a small vocabulary change, but it does help sort of, on first glance explain, okay, this is what this is for. This is more of a blueprint as opposed to the word schema. So I just wanted to call that out really quickly.
Yeah, exactly. Because schema means something different, like JSON schema. It's a physical thing rather than just types. And we are doing something a little bit funky over here. We're doing types empty object as, and then we're providing it here. And so honestly, the reason that we're doing this is because we could have context, events, if I could spell, and it just gave that for us, which is super nice. It's sort of my, hidden weapon, like just have Copilot do everything over here. And you could have other things in the future, such as actions. Actors, like we have delays, etc. And so trying to stuff each one of those inside of a generic where you have like context, events, blah, blah, blah. I have no idea what that is. That's going to be really hard to memorize and just really hard to maintain. And over here, it's just
nicer. Really long.
Yeah, it's within the machine definition. So yeah, we invoke this call credit check microservice. We input the customer from the context. It's giving me an any type, but yeah. This is also probably using an older version of XState v5. And when it's done, we go to evaluate the decision. We also have this timeout after PT15M. And so this is something where it's just a string, and I could define what that string means over here. I could say, hey, this delay is, apparently it's 15 minutes. I think that's what that, yeah, 15 minutes. So I'll get over there. And then, so we evaluate the decision, and then this is basically a junction or diamond in a flowchart. But basically it immediately goes to another state depending on some context. So,
right. The bonsai tree.
Exactly.
That's what we're calling it.
So if the credit check decision was approved, we go to start application. If it was denied, we go to reject. And by default, we go to reject, which it actually makes this a little bit redundant, but just to, keep it one-to-one, I kept it in there. So start application, we invoke the start application workflow ID. And when that's done, just go to the end. And same thing here. We're sending the rejection email and it goes to the end. Now, what's really cool, and Gavin and I were working on just refactoring some logic to a state machine, is I told him that once you have a visual, you're able to see things that you're normally not able to see by looking at the code. So, for example, pop quiz, Gavin, what are some, what could go wrong here? What are some missing parts?
Oh, goodness. Okay. Yeah. So we don't, off the cuff, we don't have anything that inherently handles errors, right?
Exactly. Yeah. Yeah. And,
so, we do have the notion that, hey, if you scoot over to the left a little bit, we do have a notion that, hey, by default with evaluate decision, if we don't make it to approve, we automatically reject. But what if it, there's no context to the reasons why something might be rejected or something like that. So that's what a good error handling would be able to provide, right? Like a reason, a failure message, things like that.
Yeah, exactly. So, he identified 2 missing parts. I was only thinking of one. We're missing the error over here.
Mm-hmm.
But yeah, so any one of these can fail. And so we
Mm-hmm.
do need to, handle that. We won't in the stream, but it's something to keep in mind and something that having a diagram makes visually clear.
Yeah, definitely helps.
Mm-hmm. Angelo says, "Ooh, nice. Does delay name resolution like that work in the editor?" And it should. I will have to double check on that after the stream, but I believe it does. And if not, we're updating our machine extractor components so that it works with XState v4 and XState v5 so that you're able to see those. But I'm pretty sure that it's going to output like that. Yeah. So yeah, we have our actors too. Just want to talk about these real quick. Because I did promise Gavin that V5 was more actor oriented. So sorry, that was an
I like my actors.
Yep. And so yeah, you could invoke promises, callbacks, observables, reducers. We call it from transition, not to scare you or anything. And of course, other machines. And you could also interpret them too. So actually, if you want to use XState and you're like, I really don't want to use a state machine, I just want to describe my logic some other way, then you can. I mean, there's nothing really stopping you. You get fewer features and fewer benefits and you lose the visualization, but it's very, very easy to just chuck your logic into from whatever and then just interpret it. So that's what we're doing with the promises here. And I have a fake delay over here. So yeah, could approve. We could send the email. Everything is good. And then we just start the actor. And this is in a node environment, so I'll show you how you could run these. Any questions or?
I just have a quick comment to make. We definitely showed from promise, which is like one of the most common sort of actor logic creators we'll be using in XState v5. But we also have several others, things like from transition, like you mentioned. There's from callback, from observable, and I think from event observable.
Yes, from event observable.
Nailed it.
Yep. And also you can make your own too. So if you want like a from WebSocket or from I don't know what else there is, but I'm sure that there's other stuff. Then you could do that too. From RPC or something like that.
From DB row update.
Well, yeah. From
that's contrived.
From Postgres, from Prisma, from whatever data layer. Yeah, there's the possibilities are endless. So what I'm going to do is just run. I'm using pnpm, but I think this will work too. npm start, and if I press enter, we will see that. All right, that was pretty fast.
Did our delays get hit?
I mean, the delays were supposed to be hit. Check credits, start application. Let's run that again. Otherwise, I might have to add. Oh, yeah. So there was a little delay, although I did forget to add delay here, just because we do want this to be realistic. Call credit check microservice. Yeah, let's say that this just takes a while, 3 seconds. All right. We're waiting. Okay, it's checking credit, and that went pretty fast. And then we see that we received this event, we received our customer the score, and the decision was approved, and we have a reason of a good credit score. And then eventually this just ends. So if you were running this in a server full sort of way, it would just be a matter of running this file. Serverless, it's definitely possible, and I have a PR in progress that actually shows that, but the mechanics are a little bit different. You would send an event, and once you send an event, you would transition the state machine, and then you would save that state to a database or something, and then you would say, okay, my job here is done. Wake me up when you have a new event for me.
Yes, 100%. And this is sort of work that we've done before, just sort of validated the art of the possible. And I personally can confirm that we were able to get this working with AWS Lambda functions specifically the vanilla Lambda functions. We didn't have to worry about things like step functions. They're durable variant because the nature of having that database as a backend gives you that durability, right? So if the goal was to, save a little cash on your monthly AWS spend, you can get around if you already have a database, a DB instance, and, an event-driven serverless function.
Yeah, exactly. And we've heard stories of people doing exactly that. It is something that we definitely want to make more of an official pattern, or like patterns that, you could just use and say, okay, I've created a workflow in XState. I want to deploy it to Lambda, or just on my own infrastructure. It doesn't have to be Lambda. Yeah. Gavin and I both come from Microsoft, so if you want to do things in Azure, then,
Yeah, we can cry together with it.
Oh, yeah. That wasn't that painful. Durable functions are really, really cool.
No, they're awesome. So, yeah, they're awesome. By cry together, I merely mean we can chew on a problem together. That's my my Gavinism there. It's a turn of phrase.
All right, I'm gonna share my screen again, just because we're gonna copy paste the thing that we're gonna be working on, which is online food ordering. And at first I thought, like, I'll do this later because it looked a little bit daunting, but I don't think it's actually going to be that daunting. So, what happened? Oh yeah, that's the image. So in this example, we want to create an online food ordering workflow. The below image outlines the workflow structure and the available services. All right, so this is like it's a half-assed state machine, but I understand why they made it like this. It's okay. So we're placing the order, which is a subflow or an invoked actor in XState terms. And so send order, estimate ETA. I guess those are two parts of that subflow. And then wait for deadline. Not sure what that is, but I guess it will explain to us. Deliver order subflow. We dispatch the courier. They pick up the order, and then they deliver the order. And then the order is charged for, which seems interesting because every other like online ordering workflow, they charge you first. Like, yes. Regardless of if your food comes or not, they will charge you, which I guess makes a little bit more sense, but we'll go with this flow for now.
Well, this works for drive-through.
Yeah.
Yeah.
No, that's true, actually. Because, well, what are you going to do? Are you going to grab your food and drive away? Like,
exactly.
They're going to be like, oh, no, we lost $7. No, it's not going to happen. Okay, our workflow starts with the place order subflow, which is responsible to send the event order to the requested restaurants. I'm guessing
a subflow in this case you mentioned would be sort of like it would be an independent actor, which I guess you could. What's a good parallel between that and V5 and V4? Would it be a child machine?
Yeah. So it would be an invoked machine. Like we have a step, which is what the subflow implies, and that step, which is not an XState term, I'm just explaining, or task if you want to call it that, that invokes the subflow, and then, once that finishes, we go to the next step. So I'm just looking at, I think this is the main food order workflow, where we place the order, wait for an ETA deadline. And so, so this is a place order subflow. And yep, all right, cool. So it gives us everything. We have the place order sub workflow, deliver order sub workflow, and then workflow results. Cool. Nice. So 3
they give us the answers
instead of 1. So what I'm going to do is, again, painfully switch back to VS Code. And I need a better way of doing this. Maybe the better way is just me closing the thousands of tabs that I have open. Thousands of windows.
You'll never change, David. I've given up on you.
Yeah, that day is not today. We are... I need all those windows. Like, you don't understand.
You need to build a workflow for us just evacuating all your tabs, writing them to cold storage.
Yeah. All right. So let's open this up. All right. So I have a nice empty file. I actually just copy and pasted like one of the one of the workflows, and then I just deleted everything that wasn't necessary. But actually, let me see if I could make this. Sweet. I can make this a little bit bigger in StreamYard. That works out great.
Nice.
So here's what I'm going to do. First, I'm going to do my secret, and I'm going to copy and paste the YAML. Yeah, the reason I'm doing this is just to give Copilot a little bit of context on what we're working with. And this is the main food order workflow. So
how do you feel about making the terminal disappear just for now, David? Give us some more space. There we go. Thank you.
All right, cool. So we start within ID as I wait for Copilot. I just have to be a little less lazy, but this is food order workflow. And so our initial state is going to be, place order. And then we have a bunch of states. And then let's see, we have place order here, which hopefully Copilot picks up on. All right, I'll stop being lazy. Actually, I'm going to be lazy in a different way. So we have a state over here. This is place order, and I'm just going to match their casing over here. And then we have deliver order. So this does something, and then we have
thing happens.
Yep, deliver order, and then we have charge. It's spelled charge for order. And then this charge for order state has an end true, which again I don't like. So I'm just going to say order finished. Nice and explicit.
Order complete. It's a final state.
Yep, give this a type of final state. And then those are basically our states. Let's see about events. So we have a subflow over here, and that's our place order workflow. It's actually a little bit easier in the old version of the editor to add invocations in code. So I'm not going to do it in here. Otherwise, you have to go in here, and then, just add that there, which is it's actually not that bad.
Yeah, it's not. Yeah, right.
And then now this
invocation.
Yeah, this automatically does like this whole done place order workflow type of thing.
And while we're here, would we like to put in, I know it's not going to be in the base flow there, but we know we have this done event here. So should we, as force of habit, just throw in a placeholder for on error?
Oh, yeah. So on error, it's not going to do anything. Oops.
Yeah, we don't need it to. We just have it.
Yeah, so it's just going to, I guess, go back here. Or
the reason I like to bring this up is because when you're modeling your flows visually, it's really good habit to say, okay, whenever I'm invoking a promise or I'm doing something that can go wrong, it's good to just have a potential error state. You don't have to fill it out now. As developers, we love to focus on the happy path first, but it's good to be able to come back to your visualized machine and go, oh yeah, here's where I fill in the gaps. Here's where I go ahead and start building those, error handling scenarios and things like that.
Right. Yeah.
And I'm off my soapbox.
No, it's good. It's really good. You should always, and honestly, this is one of the biggest mistakes that I see. I don't know about other ecosystems, but I'm just going to say JavaScript developers make, is that they're like, hey, async await is super convenient. All I had to do is async whatever. And it's like, no, you also have to handle errors. Like,
yes.
You are missing a critical step.
Promise.reject still happens, guys.
Yeah. All right. So done. And then I'm going to transition this one here. And we're going to clean this up a bit. And then we're going to go to code. So that's our nice, beautiful. Yeah. Our nice, beautiful state machine. And then, let me turn word wrap on, just because that layout string sort of gets in the way. But now we have a lot of our stuff, in already. So we have our place order workflow, deliver order. So let me just go in here. I know that this is actually pretty tough to read on screen, but
yeah, it's a bit gray on gray, but just narrate as you go, and I think we'll be okay.
Yeah. Here's another weird thing, and you can't see it, but It has transition charge for order. So what this means is that when this is done, so this state represents a task, and the task is this deliver order workflow. The transition, once that's done, is to charge for order. And so we just represent that over here, which, it's fine. By the way, this is shorthand for targets, charge for order. And I'm just going to make it a habit of, just putting these in objects. And on error, both of these should be target failure. Okay, so charge for order. Let's see. Couple weird things here. We have the charge for order function, which I don't know why it looks different than these, but that's besides the point. Invoke. So our source is going to be that. Copilot, sort of actually had the right idea and wanted to match the casing of that. And I might just let it do it. Okay.
Yeah, that works. It doesn't have to be correct. It just has to be consistent.
Exactly. And then we have some input over here. And this is going to come from... Okay, so we have the context, and it's going to come from context.order. Actually, so
and we're mapping that directly to the arguments here, right?
See, this is some of their decisions. At least with the examples. I mean, the workflow spec is great, but they're passing in order as the order ID. So here's what that looks like, and that's why it's confusing. Order is context.order.id. I would have done this.
Yes, I agree.
Or I would have passed in the entire. Actually, no, you don't need to pass in the entire order. Well, whatever that principle is called, like least responsibility
least common response. Oh, what
was it called?
Oh, I know exactly what you mean.
Yeah. Oh well. And then we have on done, and so the target is going to be order finished, which we have down here. But also we do need to save some things to the context. So actions, which we haven't even defined our context yet, but that should be pretty easy. And we are going to basically try to do this. Action data filter results outcome.status to state data status. So I don't know if you're confused. I'm a little confused, but
it looks, it's like to state data. It feels like, hey, this is something that we care about persisting, but I'm not sure. I haven't seen this syntax before.
Yeah. So basically, if we were to translate this, in fact, I'm going to let Copilot do that just to show you like what this is actually going to end up being. This is close enough. And this
data results. Okay. Yeah.
It actually is output.results.
Yes.
That's
another change with V5, correct?
Yeah. And so, by the way, the reason for that change in particular is because data is a very conflatable term. And so, it's like, what is data? Also, machines and actually all actors have input now. So it's like if something has input,
you would expect output.
Yeah. So, and the output is exactly what you expect. When an actor finishes, it finishes with some sort of output that it provides to you. So that's why we have output over there.
Yeah, I think it's a good vocabulary change. It's really good to say, hey, what's the result of this? What's returned by this thing? This thing being an actor, which could be any sort of service or another machine running as an actor or what have you. Right.
Let's see, there's also this state data filter where it's order ID, order status plus equals order complete. It's I said
without final state data
filter? So you know what? We'll worry about that later, but what I did want to show you is that like I was talking about before, we have output. And so you could actually map, your context or whatever to, let's just call this message order completed.
No. Sweet. Now, let me just ask you, David, I'm just going to ask you, we've got this output here. We've defined this output. It's on our final state. So when an actor is completed and we wanted to ingest the output of an actor from another machine, we're ensuring that here, right? If we wanted to like feed our entire context from this machine, would we just blow that out? By blow it out, I mean, put it in our output and then we can consume it wherever.
I mean, nothing is stopping you from doing this.
Yes. But that's or even just the message, right? If I cared about, hey, once this actor is done running, once it hits its final state, I want to be able to evaluate its output and programmatically make decisions based on it.
Oh yeah, I mean, you could totally do that. Nothing's stopping you from doing that. But giving the entire context is sort of the select star. You you don't really want to do that. There might be stuff there where. Yeah. Okay, so in summary, we have this actually it's a pretty simple workflow: deliver order, charge for order, and then the order is finished. And also we have to actually have our order in here. And this is where the magic of Copilot comes in again. First, I'm going to give it some types. So context, and this we're going to let it think and do its thing. Cool, we have an order. And the order is going to have an ID. Good job. That's it, which is fine, totally fine for this example. Okay, and actually that's really all we need. Again, the types are yelling at us here, but that's because this is running. Oh yeah, we also have the status. Don't know why I didn't pick that up. So status, it could be string. Yeah, I'm trying to see if it actually had an explicit status, but that's okay. We'll worry about that later. But at least TypeScript isn't yelling at us anymore. This is a status, and we're getting that from the output of this actor. And fantastic. that will be strongly typed one day too. Okay, so now we actually have to implement our services. And so this is a second argument over here. I keep saying services, it's actors. So yeah, we have a few that we want to implement. The first one is our place order workflow. And I'm just going to have this be a from promise. And I think in a follow-up stream, we'll get to actually like implementing these in the sub workflows or the subflows that are defined in the serverless specification. But for now, we'll just put stubs in there.
Yeah, it's fine.
Yeah. So I'm just going to say, wait for 1 second, because it does this pretty cool thing.
Nice.
I wish it were built in. It's not built into JavaScript.
Built in XState. Yeah, that's okay. That's what Copilot's good for.
Exactly. Cool. Let's see what else Copilot could do. We have 2 more to go. Deliver order workflow, where it wants us to wait for 2 seconds. I don't know why. That's totally fine. Okay.
It takes a little longer to deliver an order, and Copilot understands that. Money has to exchange hands. It's a whole thing.
Of course.
Nice. And again, just mapping this back to XState v4, this would be, we're calling them actors, but this maps directly to services. And we're calling like these from promises and stuff like that. But, everything you're used to doing with, calling in source and having your function reference there is essentially the same here, just with some vocabulary changes.
Yeah, some vocabulary changes and a tiny bit of structural change too, because before in XState v4, you got the entire context, the entire events, and then you created your actors using that information. But now that actually was problematic because it tied the actors directly to the machine. So they were tightly coupled. And so now they're loosely coupled. Like these actors, deliver order workflow, place order workflow, you could use them in absolutely any machine that you want, because no part of this type or the type of this actor relies on this machine. It just needs input.
That's super fair. Yeah.
And actually,
and specifically the input, instead of feeding it the entire context, right? You only feed it what they need.
Yeah, exactly. Let's see. We have place order workflow. We have deliver order. None of which actually take. None of which actually take an input of any sort.
Oh, really? We don't have to feed any of these an ID?
Yeah, the last. Yeah, it's weird. Only the last one does this charge for order function. So I'm going to assume that that we're getting that at the very beginning, just for the sake of this example. So we get the input, and then our order is the input.order. So we have that, and let's be a little more explicit here. Status is null.
Nice.
Yeah, or the status could actually be something like order pending or something.
Yeah.
But we'll keep it as null.
And again, for any newbies, that's just us defining our actor's initial context, like what it starts out as. It's brand new to the world. It has no status, and it just knows that when I was instantiated, I was given an order ID.
All right, so let's actually, I think we're ready to test this.
Oh, sick. Let's do it.
Oh, okay. So our input is going to be in order. I believe, input.order. And the ID is going to be
Gavin Slippers.
URG3R.
Oh, elite speak.
Let's see if
or whatever.
I was hoping it would give me some more examples, but it didn't.
Copilot.
Some more lead speak food items. Come on, let's have a little fun. Yeah, nice. Obviously burger.
Come on. Sushi.
Love that. Okay, cool. So you could order sushi. We're having fun. It's a Friday. More sushi.
Yes, it's great.
I want something else. Sorry. Tacos. I love this. This is great.
Having way too much fun with this.
Yeah. All right, sushi, tacos, chicken pesto. Ooh, that's a fancy one. In fact, I might need to use this one.
Yeah, let's do that. That's a really good one. That's a really good one.
That is great. I mean, you could even like put a 7 there.
Yes.
Get a little bit creative with that. Okay, so enough toying around. Let's actually test this out. So we're going to cd into our. Oh, did I? I think I overwrote the workflow credit check one, but that's okay. That's what source control is for. Wow, that's how you know it's a Friday. All right. So, but let's actually start this and try it out.
Cross
see what happens. Again, we are logging the received events, and when the workflow is completed, we get the output. So, all right, we received chicken pesto, placed the order, delivered the order,
that sucker,
received the event, and the order was completed.
Woo!
All right, so that is the first part of our workflow, and of course, to end things with the state machine, I'm going to open the visual editor here and show you our somewhat completed. I mean, Gavin will say we are missing an error thing over here, which we can just add there.
I'm the try-catch guy of the group. It's okay.
Yeah. I'm honestly much more of a coder than I am a low-code person. But honestly, when you're working with state machines, it's sort of like it enhances the code you write. And also there's things that are just like a million times faster than coding, like doing this,
Right. And just having this stub there. Yeah. It's this interesting nexus between low code and low code and full implementation, sort of like a static analysis plus, I think.
Yeah, exactly. That's the way that I like to think about it too. It's like you have visual static analysis, if that makes sense. So yeah, also, I just want to show you what I'm going to do is just copy this entire file and then stop my screen, and I'm going to present again. Sorry. This one should be faster because we're just switching to this one.
Mm-hmm.
And let's go to state.new. I was probably working on something, so you might see something here. Yeah, I was. What I could do, don't know why that jumped there. That's okay. Is I could import this and I could show it over here as well. This is our new designs. Needs a little bit of auto layout love, but yeah.
Mm-hmm. I think it's pretty good, honestly.
There you go. And then we could just show like, hey, this is how our workflow works. Here's how you finish it and everything. And one more just for fun thing that I want to show again, because it's Friday. Let's go to, I just want to go to Chat GPT and I'll show you why we're doing this. Because you're probably being like, what is he planning?
I am curious.
Yeah. So I copied the YAML definition. Here, I'll just show it over here. And so I'm going to say, make this into an XState state machine. Not sure if you could see that well. There we go. Make this into an XState state machine. And then I copy and pasted the YAML. And let's see, it's not going to be fully correct, but it's going to get stuff done. And it's going to rename some stuff. And it's also going to explain the machine for you. So if I copy this code, go to state.new, and I just take the code and I import and paste it here. It's going
it's not perfect.
It's not the same machine, but what's cool is that it, gets pretty close. And then we have an ETA deadline event. So place order, deliver order, charge for order, end. So it was able to translate that and basically do what we did imperfectly in less than a few seconds. So,
but it does give you a good starting point.
Yeah.
A really good starting point. That's cool.
Yep. Just to answer a question in the chat, I just joined, but I wanted to ask, can Stately be used with any TSJS app, or do you need to use it in a React app? What's the answer, Gavin?
The answer is absolutely with any TS or JavaScript app. We have several sort of accessory libraries out there. We do have, an XState React library to handle those bindings there. I do believe we also support Vue. But yeah, no, you can use it in any vanilla JavaScript app or not, or with any frameworks that you feel happy with.
Yeah. And so part of the reason behind these streams that Gavin and I are doing is because we want to show people that these could run on the server side too. So
yes, ubiquity is our goal.
And we'll be showing more demos and examples of that. But yeah.
Like in our case, we just did our demo. I know you said you just joined Select, but we just did our demo and it was all in Node.
Yeah. Yeah, so I recommend you, just watch it again. We go through two examples, one of which we're just explaining and the other one where we actually make it. So, yeah. All right. Well, this was fun.
It was. Thank you for having me.
Yeah. Yeah. All right. And of course, thank you for being here and happy Friday.
Happy Friday. We did it. We made it to the end of the week.
Yes.
I'm proud of us.
Also, thank you all for watching, whether you're watching live on the stream or later. Let us know what you want to see in the future. We're going to be doing a lot more of these, having some fun, making state machines. And yeah.
+1.
All right. Well, have a good Friday, everyone.
Bye.